Welcome to a new episode on the Technomora channel. We really hope you will enjoy watching it and invite you to tell us what you think of it by leaving your reactions below the video. And now, please allow me to present your host, Technomora.
Yeah, the main board is laid bare right now. And so this is obviously the TV part. The radio part is buried down there. All right. So it would seem that the TV part, which you see here, would be probably the best candidate for the first repair, namely the error in the vertical deflection and possibly the disappearing of the image, the collapsing of the image. Before we can remove the main board of the combo, the easiest thing to do to be able to move it out of the way is to unsolder the grounding of the CRT, which is a braided wire which is soldered right here to the main board. Alright, I'm monitoring the voltage on the collector of TR19 on the schematic, this one right there. And right now the collector measures at plus 9.4, 9.5 volts. And it's in fact that transistor down there. Let me show you, and let me shine some light on it. So I'm measuring the voltage on that transistor down there. Alright? There. So, yeah, the voltage is right now at 9.5 voltage, 9.5 volts, and I do have a normal image. Well, I mean, there is no pattern generator connected to the TV right now, but I've been seeing this image here for the last 15 minutes or so, and yeah, it's staying like it is right now. So the voltage is a bit low. According to the schematic, it should be let's see, 10.3 volts. So it's not extremely low, but it's a bit on the low side. But the TV continues to function normally, and which is typical, of course. I mean, I've been having the intermittent fault all afternoon, and now suddenly the TV seems to be working just fine, which is typical. If you want to show it, the problem stays away. When I cool the power transistor off, yeah, you see the image suddenly disappears and the voltage drops at 8.2 volts. So what I'm thinking is, since you see there, that's and now it's back. So what I'm thinking is that that transistor is faulty, although faulty in the sense that it's probably spent. So I'm considering replacing it, and then have the TV run for maybe an hour or so, and then see if the fault appears again, you know. But yeah, I would say chances are high that the source of the fault is that transistor right there. Yeah, you see? And now the image is gone again. Alright, so I figured out that the power transistor on the main board of the crown is a 2SD 313, and I'm going to try replacing it by a sort of a general purpose power transistor, which is a TIP-131, which is the one you see depicted here. Alright, and the specifications of the TIP-131 are rather close to what it should be in comparison to the 2SD313 I'm planning to replace. In fact, the TIP-131 is slightly better. The collector emitter voltage is rated at 80 volts, and the collector current is rated at continuous charge or load, I should say, 8 amps. Yeah, so you see it right here. Current collector, 8 amps, continuous load. All right. So yeah, that should do the trick. But of course, I need to unsolder the 2SD313, and it's this transistor right here. I don't know if you can see it. So right there. This is the transistor I need to unmount. And it is indeed a 2SD313. I don't know if you can see the code on it. It's marked D313, but they often drop the 2S qualifier. So this is the one I'm going to replace by a TIP-131, which is this one here. Alright. Alright. As you can tell, the legs of the original transistor are bent a bit weirdly. Yeah. So I tried to emulate the bending of these legs, or if you wish, the leads, to resemble more or less the leads of the original one. So that should facilitate mounting the new transistor. I switched over to my mobile camera instead of the fixed one, because I'm still looking for the fault. Alright, and you just saw the image reappear. Now, when you look on the schematic, you see a horizontal frequency adjustment coil here, which is in fact the one with the white knob you see here. Alright, so this is the horizontal deflection frequency adjust. Alright, and it's in fact the spool L601 on the schematic. Alright, now come on. Now, as soon as I start fooling around with that spool, so adjusting it, the image collapses almost immediately. So that would suggest that there would be a fault somewhere there on the schematic. Alright, so the values around TR17, when the image is, let's say, quote unquote correct, are okay, but there seems to be something not quite right there. So I'm thinking that since I replaced all the electrolytics on the main board, and since I replaced the transistor TR19, yeah, that one is good now. So, and I didn't touch either TR17 or 18. But look at what the image is doing right now. Okay, so there is something weird going on around the horizontal deflection circuitry. So if I move the horizontal frequency adjust, look, you see, the image almost immediately collapses. Well, okay, now that's typical. Now it doesn't, but oh, okay, there it goes. Okay, so yeah, there's something wrong with the horizontal deflection circuitry. Alright, so, and that of course in turn influences the vertical deflection. So yeah, so around this part here, and more specifically, that is TR17 on the schematic. So TR17 is right here. Alright, so what I'm going to do is I'm going to switch off the TV, and I'm going to start measuring the values of the components around TR17 and possibly around TR18 as well. If you look closely at the transistor's pins, yeah, you'll see that the pins of the transistor are blackened. So, okay, so, and that is a telltale sign that they are silver coated. And I have the impression, I've had problems with transistors before that had the same phenomenon, so blackened contact leads, okay. And generally that would mean that the silver coating on the contact leads is well, are corroded, you could say, are oxidized, yeah, and it's quite possible that we have a case, a sort of a case of silver migration, a problem which is common to IF transformers. So, yeah, I'm going to look for a valid replacement for this transistor. We're going to replace it on the PCB, and then we'll see how the TV will behave. Alright, so I've been studying this part of the schematic of the crown combo, and which this specific part is the horizontal deflection circuitry, at least part of it. Now I'll remind you the symptoms that the combo is displaying, which is that at very intermittent times the image collapses completely and becomes very faint and is completely jumbled. The other symptom is that neither the vertical nor the horizontal deflection seems to be very stable, so it doesn't seem to want to lock and stay stable. Yeah. So I started replacing. In fact, I replaced up until now these 3 transistors. All right. So I replaced this one with a TIP 131 NPN transistor. This one with a BD 139, and this one with a BC 546B. Right away, I can tell the image quality has improved. It's still not perfect though, but the distortion we had before, on a left-right basis, you could say, was markedly more important with the original transistor 18, so the 2ST467. But like I said, the BD139 seems to perform just as good as the original one, and even better. But as you can tell, the locking of the image, so there's still some drift on it. Not a huge lot anymore, but the TV definitely has still some trouble locking in on the signal, and there's still some distortion on the horizontal deflection. So we will need to continue our search for the possible cause of the distortion and the instability of the locking of the vertical and the horizontal. But I would say it's an improvement. Now, what could be the cause? Well, what could have been the cause for the distortion originally? Well, it is my guess that this little transistor was never meant to dissipate as much power as it is rated for, okay? So, I mean, to put 700 milliamps through such a small transistor case is really not a good idea. Now, that does seem to have helped somewhat to improve the quality of the image and the stability of the locking. But the improvement until now is, I would say, marginal at best. Some of you might argue, but yeah, why replace these transistors if the original ones still seem to be good? Well, I did it for 2 reasons. First of all, 2 of the 3 transistors were suffering of silver migration, which is, you could call it a quote-unquote disease, which some old components with silver-coated leads suffer from, which is in fact silver oxide migrating into the component and therefore disabling it. Yeah. The other reason is that I'm still learning, doing electronics. And I was just curious to see uh, how to replace old style transistors with new common ones. Because let's face it, old parts are harder and harder to get by. So I thought it would be interesting to see which new parts would be able to replace the old ones. Yeah? And it turns out that my choice of parts worked out just fine. Okay, so, and that's a good thing because, those parts are cheap, they're readily available, anybody can get them. Yeah? Unless, of course, you're a stickler for sticking to the original parts. Yeah, if you want to keep the originality of the circuitry, yes, well then, unfortunately then, you'll have to look for original replacement parts. But let's face it, the original ones will also suffer from silver migration disease. So yeah, it's a choice I leave up to you whether to stick with original parts or new ones that work just as well, if not better. Now, replacing the transistors did improve the functioning of the combo somewhat, but the improvement is, let's say, marginal. Let's say it's a little bit more stable. There's a little bit less of collapsing going on of the image, I mean. Now, you'll notice that the collector of the power transistor here goes to the high voltage coil here. Yeah, so it looks a little bit like a transformer. All right, so right here is the high voltage output which goes to the CRT. Okay, so if you follow up the schematic, you see here HV, high voltage. So that's where the high voltage goes to. Now, although this looks a little bit like a regular transformer, say, with what you might construe as a primary and a secondary, in fact, I would be tempted to say that the high voltage part of the transformer, so the flyback in fact, works more like an autoformer. So that is to say, just one coil instead of two. So you could temporarily ignore this part of the transformer. Now, one thing is for sure, that is that if and when the high voltage drops, yeah, the image will collapse. So this is not something nice to have, it is essential to get a good image on the CRT. Now, if the high voltage collapses, then the image will collapse as well. So I started thinking, but I measured all the components you see here, all of them. Yeah, the capacitors, the resistors, and I replaced the electrolytics, and I even replaced the 3 transistors, and still the fault remains. So I took a little bit a closer look at this part of the schematic. Let's see if I can enlarge the picture somewhat. Okay, so I took a look at this part. Now you'll notice that the output of the power transistor here, so you could say this is a driver transistor, okay, goes to 0.3 on the high voltage coil here. Yeah. And then if you go a bit further on the coil, you see at 0.4 here, and you go back here, you see there are 3 capacitors connected to it and a diode. Alright? So, and those are located right here. So, right there, you see these here, these capacitors here, these, and underneath the yellow wire you see the diode right there. Okay? So those are those 4 components. Now, I'm beginning to suspect, and I have to admit this is for the moment just conjecture, but I am thinking that if one of these capacitors, or all 3 of them, are leaky, yeah, so they are starting, and I mean by leaky, I mean electrically leaking, they are starting to act as a resistor instead of a capacitor. So if one of these, or all 3 of them, are leaky, then they will shorten the voltage that goes from the power transistor here at 0.3. They will shorten that voltage from 0.4 down to ground, which is this fat black line here. And that, of course, would explain why the image on the CRT collapses. It would seem the crown combo has a lot more problems going on than I initially thought. I'm still hunting the source of the collapse of the picture, and right now I'm measuring the signal of the horizontal tracing oscillator, which is this one, TR17, and I'm measuring right here at the emitter of the transistor, which is on the print board right there. Alright, so you can see the trace over there on the oscilloscope. I would say for a horizontal trace that should be normal. If we set the frequency tracing like this, yeah, so the trace frequency is 14.29 kilohertz right now. Now, mind you, I've messed around with the horizontal sweep frequency by turning the horizontal sweep setting right here. Okay, but let's say we're somewhere within the ballpark of the right frequency. Now you can see the image just collapsed, and now we are seeing these signals here. Alright, so very sharp peaks downwards. Alright, and in a moment these peaks will disappear, and in fact there are several little peaks, as you can tell right here. Okay, so there are several peaks, in fact, or you could say tiny little square waves, yeah, which always precede the collapse of the image, as it is right now. Okay, so the image has completely collapsed, but in a moment or so the image should return, and then the square wave should be clean again. Well, I say square wave, let's say the waveform should be stable again. Okay, now My problem is this error is very intermittent in length and in occurrence, and I still haven't found what the cause of it might be. Some things that I do by, for example, changing or trying to change the sweep frequency or even the brightness or the contrast seem to have, let's say, an influence on that collapse of the picture. Not always, but sometimes it has. And right now it's lasting a mighty long time. Normally it should return to normal within, let's say, 30 seconds. And I've been talking for at least a minute now. So yes, the crown has a very big problem, and in its horizontal sweep. And hunting it is taking a mighty long time. I won't give up, of course, but still. I'm at the end of my, say, time slot to devote work on the crown. So I'm probably going to end the video right here. Okay. Unfortunately, I can't say there's much progress, but like I said, I'll keep hunting for the cause of this error. So yeah, there you go. That's what I'm doing right now.